So we will continue our discussion.
I'm just like, oh, a lot of allergies in here. In here.
So, remind, where we stopped, we didn't draw the graph, right?
For what?
It was like right up the stairs.
Cosine graph, we
Oh,
stopped,
no.
we stopped at 7, right?
Oh, yeah.
So I'll go a little fast today because I want to complete all the questions. Yeah, we have three more questions. Stop me if you have any questions. We can, get into details. So these two parts I think I want to discuss. It's not in the video, so it's secant theta equal to secant theta equal to secant theta equal to, you can write as cosine theta equal 1. Everybody? Secant is 2 mean, cosine 1 over 2. Okay? 1 over 2. So now you have to tell me where cosine become 1 over 2. You can see the unit circle. I'll quickly draw part of the unit circle. So this is how the unit circle looks like. This is 60 degree. Okay? 60 degree related to half. To really need the coordinate, this is pi over 3. So one of the answer is pi over 3. Can anybody tell me the other one? Where are the cosine positive? You have to think about that. Cosine positive in first quadrant and fourth quadrant. Yeah. That means if you look at this point, it's also half. But this is changed, it's okay, because this is related to sine. This number related to cosine. So what is this angle all the way to this? It's just 60 less from 360. Yeah, pi over 3, which means 300. You can write it like 60 degree, 300 degree, it's also okay. Last one, this type of question, last one, tan theta negative 1 over root 3. 1 over root 3 related to 30 degree. Okay, that's the reference angle. Okay, again I'll draw part of it. You don't need to do that all the time. You just tell me what the two angles. Okay, this is kind of explanation. 30 degrees here, pi over 6. This point, root 3 over 2, half. Root 3 over 2, half. This is cosine pi over 6. This is sine pi over 6. Tan you can get by dividing this half by this number. So tan value is 1 over root 3. Okay, tan value is 1 over root 3. But I don't need 1 over root 3. I need minus 1 over root 3. Okay? Tan will be negative here and negative here. Agree? So I know the reference angle is 30 degree. That gives 1 over root 3. So this is the angle here, pi over 6. And I have to have an angle here, pi over 6. Okay? That means you have to come all the way to this. Pi over 6 means 30 degree. So it's like 150. 150 means pi over 6. Do you guys have any questions on that? How I get that pi over 6? Because pi over 6 related to 1 over 3. That's my reference angle. But I can't choose pi over 6 because it gives me positive number. This is negative. Tan negative in second or fourth. second quadrant I have this angle 30 mean what is my entire angle here? 150. 150 I can write in radians 5 over 6. And the other one is what? This is like 300, so 360 minus 30, which is 330. Okay? 330 is same as 11 pi over 6. Okay. First you understand the reference angle that gives you the value and then find the correct quadrant. That's all you do. Because I know anything here or here would not give me minus. Good? Yeah, I have. Yeah, this is yes. Okay. Fine. Clear? Any questions on that? So we're going to draw the graph, okay? If you don't have any questions. I'll start. This is close to the camera. So question number 8. Determine the amplitude and period of y equal to cosine 3x. What is the amplitude mean? How much the wave go up and out. Okay? So it's determined by the number, you know, the number in front of your sine or cosine. So that's 2. Period is 2 pi over this number. You may remember it's like 2 pi over b, that's the formula. Okay. 2 pi over 3. It's little strange. 2 pi over 3, if you need in degree, you can write it's 120. Okay. The reason I just write 120 because it's easy when you mark or x-axis. Okay. There's no phase shift here in this graph. This is just a regular one. Okay. So you draw your y-axis. This is your x-axis. You change x, that means you change the angle, your y change. Let's go up to minus 2. Okay. Cosine graph, anybody that now you have to think about where I should start. Sine graph look like this. Like cosine is somewhere here, right? So that means start here. But what is the period? 2 pi over 3. Now you have to divide that by 4 pieces. You take the period and divide into 4 pieces. If you ask me why I should do that, because it's like a 4 quadrant. Look at this. If you have this is like a 1 quadrant, this is another. It's like a quarter. I think 1, 2, 3, 4. Okay. So this is 120. You know, it's easy when you understand it's in degree. Can you tell me quarter of 120 is what? If you divide 120 by 4, 30. So 30 is my quarter, which means 5 over 6. What is the half of 120? 60. 60 means 5 over 3. So see, it's very easy. If you deal with this is tricky. You can divide by 4 and get that, but it's easy if you go with degree. Okay. What is the 3/4 of 120? 75% of 120? 90, right? 90. Clear? Because like 330s. This is 130, 230, 330s, 430s. This is 5 over 2. It's a little surprised how the fractions going like 5 over 6, 5 over 3, 5 over 2, 2 pi over 3. Okay? You know, in my experience, I give this type of question in the finals. We discuss in final practice, but most students struggle because.
So, do we have to do the graph in radians, or can we do it in radians?
You have to be able to do any division. It doesn't matter.
Okay.
There's no restriction like that. Either radians or degree. Okay? You have to choose one.
That makes like so much more sense, because I never knew where the values came from. I just threw them on there and hoped for the best.
Right.
But that makes sense, basically.
Yeah.
Whoops.
You learn even in the last class.
Yeah, that's great. Sorry, listen, I never.
120, 60, 30, 90. Okay. Right. Now you draw. Now you know once you mark all those things and you know where y-axis like a boundaries, you all need to draw this one within that. That's it. It's just cosine. The shape doesn't change. It shrinks a little bit. It's spread up and down. That's it. Okay. So the drawing is kind of very easy if you understand what's going on here. Oops. Here you go. Okay. That's it. That's a cosine. It's cosine graph. Okay. Right. Last one. The next part. 2 cosine 3x. You need to draw this now. Using that. Let's see if I have good color. Oh yeah, this is good. 2 cosine 3x minus pi over 3. Can anybody remind me what is the phase shift now?
It's right, pi over 3, right?
Pi over 3 over 3.
3.
Can I cancel? Okay, this is my question. Can I cancel this 3 with 3? Yes. Who say yes? Wrong. Wrong, because you have to multiply 3 with 3. Okay? You see? That's the mistake. That's the mistake most students do, my question may be asked. You can answer yes, but this time no. Okay? So if you have something like this, can I cancel this 3 with this?
No.
Yes.
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 Yes. Yes. Yes. Okay.
Pi over 1, which is pi.
This is not.
No. That would be correct. Woo, woo.
Right, guys. Now you understand how much I need to bring my graph to right side. You have to shift your graph to right side. How do I know I am going to shift to right? Because of this minus. Okay. Minus right plus left. Okay. You guys do these things in Calc 1. It's like you take the derivative of those things, and you have to have good understanding of what's going on. Pi over 9. By the way, what is pi over 9? Pi is 180. Over 9 means 20 degree. Now, right? Pi is 180. So now you know this is 30. You know that, right? This is 30. So that means I have to bring this point 20 degree to right. So that means somewhere here. So see, this gap is 20 degree or pi over 9. So you can even mark it if you want. This one, pi over 9. Pi over 9 is a smaller number than pi over 6. Of course, if you divide with a larger number, the whole number is smaller. Okay. Okay. So this was 60. Now it's 40. You don't need to mark everything, but so I want to show you this is how it's come. Okay. This point goes somewhere here, very close to this. Okay. Like this. This is how. My blue graph is 20 degrees shifted here. this is my last question for you. I told you this is 120, right? Can anybody tell me where this graph will stop? What is this gap? 20. So this is 120, this is what? 140. I can show you that. It's 2 pi over 3 plus pi over 9, right? You say 140, I will show you that. 140 is in degree. But you can add this. If you multiply both sides by 3, it's 6 pi over 9. This is pi over 9. This is 7 pi over 9. I know pi over 9 is 20. 20 times 7, 140. Clear? It's verify everything that, that makes sense. That's why this gap, you can either write radians like I said, and if you really tell me, okay, this is 120, this is 140, that means I understand you got the idea. Okay, you don't need to you don't need to mark all those things. If you have time, you can do that. But if you just tell me how much you shifted and mark that first location would be fine. Right. Let's have a question number 8. Number 9, I'm gonna, I'll post a video explaining all the, identities, okay? So please, because it's the same question that we discussed in the class, like I said, I'm planning to give 2 questions from the list that I explained, that's what it is. Worksheet 5, remember? So I'm gonna explain that in a separate video and post, okay? I'll jump into question number 10. If we have time, we can come back and do a couple of questions from very fine identity. Okay? Because number 10 is the one we really need to go over, take time. Okay? Because it's we didn't discuss in details. Number 10. So question number 10. Suppose sine alpha is given, and it's not only sine alpha given, it says where the alpha lies. Alpha in first quadrant. Sine beta also given, 3 over 5, and this time beta in second quadrant. So this is like an acute angle. The other one is greater than 90. Okay, it's not an acute angle. It's in the second quadrant. Right. Now my question is this. So this is kind of a key you need to use. All students take care. So I know this is only sine positive, tan positive here, cosine positive, and everything positive in first quadrant. Right, now I'm going to draw, this is my first one. They first ask cosine alpha. Sine alpha given, okay, sine alpha given, how do you write cosine alpha? First, let me use the detail, like the information you get. Sine alpha is opposite over hypotenuse. Yeah. O over H. Okay. And if you know opposite O and H, how do you find A, adjacent? We remember it's like 13 square, subtract 12 square, and get the square root. Okay? It's 169 minus 144. Let me write one more time. Okay? It gives you 45. The square root of 45 is 5. Shall you miss somewhere? I feel like you lost. So let me see. Sin alpha, good, right? Sin alpha given in the question. Good. Okay. And I use that opposite over hypotenuse, and I use those two numbers to get my adjacent. Once I get the adjacent, I'm done. Because cosine is like adjacent over hypotenuse. But keep in mind that I have to now, before I put plus minus, I have to think about alpha is in the first quadrant. Question.
Is the first one supposed to say cosine and not sine?
This is given in this as sign in the question.
Why did we do cosine then?
That's the first question.
Oh.
Okay? Yeah. That's the first question. So these two are given. This is the question asked. They ask cosine alpha, cosine beta, and so on.
Oh,
Okay?
okay.
These are the information. Use them to find all the other ratios.
Got it.
Okay? Any other questions? Okay. Cosine alpha plus or minus. How do I know the value? How do I decide it's plus or minus? Look this information. It's first quadrant. In first quadrant, angle, sine, cosine, tan, all positive. So this is just a positive number. So you can keep it like that. Okay. You guys missed somewhere? Oh, good. Okay. All right. Now, part B.
Let's see.
Cosine beta, that's what we need. Oops. Cosine beta. Again, draw right angle triangle and use sine beta. Because that's my angle now. Beta is what? The sine beta is 3 over 5. O over h. O over h. Opposite over hypotenuse. If you know 3, 5, what is this length? Anybody? 4. It's like you don't need to even use the Pythagoras theorem. You get used to that. Okay, now cosine beta, I know it's 4 over 5. But now I have to still decide it's plus or minus. What do you think, guys? Is it plus or minus? Based on this information, beta is in the second quadrant. Second quadrant, yes, sine positive, but cosine negative. So you have to put that negative yourself. Okay, that's the cosine value. Good. Right. And once you got those two answers correct, you can just need to apply the formula and complete the others. That is, that's the kind of tricky 2 questions. These are easy. You may say it's long, but it's still, just apply the formula. Cosine alpha plus beta, cosine sum formula. If you have that in your formula sheet, you just need to, write it down, the formula, and plug the values you got. You have all 4 values you found. I mean, 2 values you found, 2 values given in the question. Cosine alpha, 12 over 13. Cosine beta, 3 over 5. No, sorry. I'm writing this. Okay. Cosine alpha, 5 over 13. Cosine beta, negative 4 over 5. Sine alpha, sine beta given in the question. 12 over 13, 3 over 5. Okay, I'll give you a little time to say it. Yes. Tan, correct. Switch this. This is negative 20, 65. Negative 36, 65. 13 times 5, those type of calculation you can do without calculator, okay? Negative 56 over 65. This is enough. You don't need to further simplify. I know in my math lab they need a most simplified version. And you had a very big numbers, but this is easy. Yes? Have a question somewhere? The reason is beta is in the second quadrant. You have to still include that information, okay? Those two angles are totally different. Okay? Any other questions? This is good. Okay. And I apply those two things I found. 5 over 13 cosine beta is negative 4 over 5. And it will give me negative 20. This is 12 times 13, 36. Okay, D. Sine alpha plus beta. Sine alpha plus beta. It's sine alpha cosine beta plus cosine alpha sine beta. That's the formula for sum. Okay. Sine alpha 12 over 13 cosine beta. Negative, right? It's negative 4 over 3 over 5. Again, you know, sine, if you have plus, this is plus. Cosine, by the way, is different. If you have plus, it's minus. Okay? Cosine alpha 5 over 13. Sine beta 3 over 5. It's long.
Very. Makes sense.
You know, keep trying and you will. It's all. It's just look you know kind of complicated, but it makes sense because we are given two ratios. We found the other two ratios, and how many ratios we have here? 1, 2, 3, 4. We use these 4 ratios different way according to the formulas. Okay. It's just kind of 4 numbers you multiply differently and get different answers. Okay, 48. But those different answers really make sense. Okay, this number is like cosine of the plus of those two angles. Okay, this is 65. This is 15 over 65. And to simplify, it's negative 33 over 65. I want to tell you something. Alpha, beta, like you know, it's like alpha is in the first quadrant. Can I choose any number in the first quadrant? Like, can I say 70? It's alpha, first quadrant. Okay, I'm just giving you a kind of idea. Beta is in the second quadrant. Can anybody tell me some angle in the second quadrant? Greater than 90, but less than 180.
120.
120. Okay. 120 is. Something we know. The cosine, for an example, cosine 120 is actually minus half. So 120, you know, that's a good answer for the second quadrant. But I know really what is cosine. It's not this. So can I change it to something else like 110? The only reason I change it because it's something, you know, 120 I know. 120, the cosine value I know. It's not this. So I change it to 110. So I want to tell you like maybe doing like 160 or something. So if you add these two angles, you will get something in the third quadrant. I know this angle is in the first, this is in the second quadrant. If you add, you go to third quadrant because you see cosine of that plus angle negative. Sine of that plus angle negative. You know in the third quadrant, both sine negative, cosine negative. I know the sum of those two angles lie somewhere here. Okay, so you can do little kind of visual geometry. You can understand. Okay, alpha is here, somewhere here. Beta is here. If you add them, it's stop here. Yeah, even though I don't know really alpha is what or beta is what, I can still get that idea. Okay. Because I know those values.
You have to say mass, and we're doing
Okay. D tan alpha plus beta. Tan alpha plus beta you can write. Let me write it here. Okay. D. I can use the formula if I want. Okay. remember I teach you tan alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta product. But instead you can use sine cosine because you found sine, right? Sine alpha plus beta is this. Can I write it this way? Okay. This is cosine alpha plus beta. You guys good? What I did here? I use sine and divide by cosine. It's the easiest way. 65 cancel out, it's 33 over 56. That's a positive number, I know, because it's in the third quadrant. Alpha plus beta is in the third quadrant, tan is positive in the third quadrant. Because when sine, cosine both negative, tan positive. Okay? And then the double angle formula. So that's our last part. Okay? Where should I erase? Okay. I'm going to erase this. Maybe here. Okay? Good. This is our f sine 2 alpha. I know sine alpha, but what is sine 2 alpha? So 2 sine alpha, it's equal to 2 sine alpha cosine alpha. I know sine alpha. Sine alpha is given 12 over 13. Cosine alpha I found, which is 5 over 13. I'll give you a little time. Okay. You must know sum formula, difference formula, and double angle. So that's the last question test. Okay. You may not need all the things because I might not give you like a lot of part. Because in this practice question we cover everything like sine, cosine, and everything. Okay, so this is what is this? 60. Oh, 60 times 2. 12 times 5 is 60. So 120 over 169. 13 times 30. He asked cosine 2 alpha. Oops. Can anybody remember cosine 2 alpha formula? It's equal to cosine square alpha minus 1. Minus? No, minus 1. Minus 1. Okay? Yeah, that's okay. You can write down, practice a couple of times, and in pre-calc you don't need to kind of memorize all the formulas. Okay? You can use the formulas. 2 cosine alpha. Cosine alpha I found over there, 5 over 13. But I need to square it because that's the formula says. It's like 2 times 25 over 169 minus 1. Take your time. Good. Right, everything going good. Okay, you may say, how do I subtract 1 from this fraction? 1, I can make 1 as 169 over 169. And 1 is like divide. The reason 169 is special because it's the denominator. Now I have to subtract 169 from 50. 50 minus 169 is minus 119. 169. That's my cosine 2 alpha. Okay. Now again, last one, 8. What is tan 2 alpha? How do I get tan 2 alpha? You can use tan at that double angle formula, Or since you know sine 2 alpha and cosine 2 alpha, you can use those two numbers and divide each other. Divide this by this. 169 cancel out. That gives you 120 over 190. That's your last. Okay. Good. Okay. All right. I'm not gonna change. I'll give you two ratios and ask kind of bunch of other ratios. Okay. Using sum, difference, double angle formulas. Okay. So I think that's the question you need to little practice because we haven't had this question in the test, last test. Okay, this is the only I think major concept we learned after test 3. Last 2 weeks maybe. But, yeah. All good. Right. So that's nothing. Especially we have to discuss. Let me see. Do you guys have any specific questions that we go over? Verifying identity part, I will include to the video, the separate video, and I'll try to do as much as question that would help you. Okay, you can watch the video during the video. All right, so you can stop. I'm gonna miss you guys. Yeah. Do well. Maybe we can meet to take. Most of you are bio majors. Maybe I might not be able to teach you. But
Maddie graduates in like a week.
oh, really? Okay. I maybe stop by. I might come to.
Yeah, I don't need help.
We'll take a photo. Okay.
Yeah.